All right, ladies. Today we're going to talk about 3-7, and that's absolute value equations and inequalities. So remember, just at the beginning, give me a little summary of what we talked about in class, a little check on how you're doing or feeling about the topic before we begin the examples. All right, now that we've started, let's talk about absolute value equations. So remember, in class, we talked about that if you have an absolute value, it talks about the distance away from zero, and you can be a number of distances away to the left or a number of distances away to the right. So when we solve an absolute value equation, we have to solve it for both positive and negative answers for the left and the right. Please remember, though, that you cannot solve as a positive answer and a negative answer until everything has been eliminated on the left-hand side. So in a minute, we're going to put down an equation with a coefficient in the front and a number that we're subtracting after the absolute value. We got to get rid of all of those first. So if my equation is 4 absolute value 2y minus 3 minus 1 equals 11, then when I go through, before I try to split this up, I need to get rid of this negative 1 and the 4 at the same time. Just like we did before, we're going to do the inverse of addition or subtraction first. So in this case, I'm going to add 1 to both sides. And I have 4 times the absolute value of 2y minus 3 and 12. Then I'm going to divide by 4. And even though absolute value bars are not parentheses, they kind of function like them if there's a coefficient in the front. So I can divide this 4 out and make that the inverse operation and cancel those out. That gives me the absolute value of 2y minus 3 equals 3. Now that we have just the absolute value part, we can separate that into two separate equations. One with a positive answer and one with a negative answer. Then you solve these just like you would regularly. So add 3 to both sides. 2y equals 6. 2y equals 0 on both of these sides. Divide by 2. Divide by 2. And I get y equals 3 or /and y equals 0. Okay, so for absolute value, you have to have two different answers when you get your absolute value going. All right, let's take a look at another one. And I'm going to zoom in just a little here. So this one is 3 absolute value 2t plus 9 plus 12 equals 10. Again, the first thing I'm going to do is subtract 12 on both sides. Get rid of that inverse of addition or subtraction. So 3 absolute value of 2t plus 9 equals negative 2. And then divide by 3 on both sides. Now, if you notice, basically this equation now says the absolute value or the distance away from 0 of 2t minus 9 is negative 2/3. Remember, we talked about that distance cannot be a negative number. You can be going to the left, which is on the negative part of the number line, but the distance amount is actually positive. So this actual absolute value cannot be solved. And if that's the case, then we're going to write no solution. Sorry. No solution. So anytime you have your absolute value equal to a negative number or greater than a negative number or less than a negative number, when it's all the way solved for your absolute value bars, then you have no solution. Make sure you get rid of all of that extra stuff first before you decide it's no solution, though. Those can be misleading. Sorry, I totally put that in the wrong spot. That was really supposed to be 2. My apologies, everybody. All right. Let's talk about inequalities now, though. So here we go, absolute value inequalities. Remember, we talked about that in your inequalities, you need to decide if it's an and inequality or an or inequality by deciding if you're going to be between the 2 points or on the outside of those 2 points. Remember, if you're between them, then you are less than that many spaces away. And if you are greater than, then you are farther than that many spaces away. So our first inequality says the absolute value of 4x plus 7 is greater than 19. So for that one, we would say that that amount of spaces has to be greater than 19 away from our value. And if that's the case, then it's going to be an or inequality because I'm going to need to be on the outsides or on the edges of this graph, right? From here and here, okay? All right. Now when we solve them like absolute value equations, but when we go to write our negatives, we need to do something special with our sign. So I'm going to turn this into two separate problems. 4x plus 7 greater than 19. That's just the original problem. 4x plus 7 and make my answer negative. Remember, when you do things with negatives, multiplying and dividing, you got to switch your sign. So in this case, I'm going to switch my sign, and I'm going to add my or in here. That way I get two different answers. For both of these problems, we're going to do the same solution steps. So we're going to subtract on both sides. Oops, here and here too. Here I'm going to get 12, and then here I'm going to get negative 26. Divide by 4. And here I get 3. Oops, wrong sign. Greater than. Notice I divided by a positive number, so no need to switch. And then here I'm going to have negative 13 halves, or if you prefer 6.5, that's fine too. Remember, it's a negative sign though. Okay. And remember, when we graph this, this is an or inequality. So as I'm looking at my number line, I want to say, okay, from negative 9 to 9, 0, 6, 3, 3, 6. So negative 6.5 is roughly about here. Open dot. Open dot. And 3 is right here. Open dot there. And then we're going to be greater than 19 spaces away. So I'm going to color to the outside of these things. Okay. So with your absolute value inequality, you're going to solve it like your equation, but make sure to flip that sign for your negative answer, and make sure you decide if it's going to be an and or an or inequality. All right, let's take a look at an and inequality. Absolute value inequality, and this one's going to be an and. So my inequality is 2f plus 9 less than or equal to 13. So again, this says this amount of stuff is going to be less than 13 spaces away. So in my graph, when I have my two dots, I need to be in between those two, less than 13 spaces away from whatever number I'm trying to come at. Just like with absolute value inequality ors, you need to split it up into two problems. 2f plus 9 less than or equal to 13. That's the original problem. 2f plus 9 greater than or equal to negative 13. Notice I switched my sign because I changed the sign of my answer as well. Go through and solve all of those. Minus 9, minus 9, minus 9. 2f is less than or equal to 7. Oops, sorry, I thought that was a 6. 4. And then 2f greater than or equal to negative 22. Divide by 2 on all sides. F is less than or equal to 2, and F is greater than or equal to negative 11. Remember, if you write that as one solid inequality, it's negative 11 less than or equal to F less than or equal to 2, going from small to large. And when I graph that on my number line, I have negative 12, positive 12, 0, 6, 6. Negative 11 is way down here, and positive 2 is right about here. And remember, we are shading in between those two dots because I want to be less than 13 spaces away from the value that I'm trying to find. All right, ladies. So that's absolute value equations and inequalities. We will practice that next class. But for right now, give me a check and tell me how you're feeling so we can see how everything's going.